this video, we'll be looking at a LeetCode problem called course schedule. So in this problem, we are given courses, the number of courses, and then it is to be determined whether a particular person can take up all the courses or not. So, and there are some conditions which has to be used when determining if a person can take up all the courses or not. So we have, for example, case where we have number of courses as 2. So whenever you have 2 courses, then you will number them as 0 and 1. So basically you start from 0 and go up to n minus 1, and then you have a prerequisites array which specifies the condition stating the dependency of one course on the other. So here it says that course number 1 is dependent on course number 0, which means that in order to take course number 1, you have to take course 0. So with just this prerequisite as an input, you can see that you will be able to, or a user will be able to take all the courses which is 0 and 1. So in this case, we will say that yes, it is possible to take up all the courses. Now let us look at one more example. Here we have number of courses as 2. So again we will number the courses as 0 and 1. Now we'll look at the prerequisites. So here it says that 1 0, which means that course 1 is dependent on course 0, and then we have a second prerequisite which says 0 1, which means that course 0 is dependent on course 1. So 0 is dependent on 1 and 1 is dependent on 0. So they form a sort of a dependency on each other, and that is why you cannot, or a user cannot take up all the courses, because both of them are dependent on each other. So in this case, our response will be false. Let us look at one more example. So let's say that we have number of courses as 4, and then our courses will be numbered like 0 1 2 3, and then we have dependency like 0 1, and then we have 1 2 and 3 2, which means, so this is our overall prerequisites array. So which means that course 0 is dependent on 1, then your course 1 is dependent on course 2, and then your course 3 is dependent on 2. So we see that in this case user will be able to take up all the courses, because he can start with course 2, and then he can take up course 1, and then he can take up course 0, and also he can take up course 3 after course 2, because that is 3 is dependent on 2. So in this case we can see that the response will be true. So this is what the question is about. Now let's discuss the solution. Some important points which we should talk about and consider before we start solving the problem. So let's go through them one by one. First is that if you look at the problem closely, you will see that it is indirectly asking you to find cycles within a graph. Okay, so there are two important aspects within this point. First is that it's essentially a graph related problem, so we need to convert whatever data is given into a graph data structure. Of course it will be a directed graph, and then we are supposed to find if there are any cycles within the graph. So if there are cycles, we cannot take up of all the courses, and if there are no cycles, then we can take up of all the courses. The second important point is that the number of courses which are given, that information is not relevant to the solution of the problem. By this I mean that, for example, if you are given number of courses equal to 10, which means that your courses are numbered from 0 to 9, and you have a prerequisites array which has just one prerequisite that says that course 0 should be dependent on course 1. So now you can solve the problem just by looking at this prerequisites array and not looking at the total number of courses, because if the prerequisites are not covering the total number of courses, then you don't need to look at those courses. You need to look at only the courses which are covered by prerequisites. So in this case only 0 and 1, and if they are satisfying the condition, then we can take up of all the courses. So in this case, since 0 is dependent on 1, so user can take up course 1 and then 0, and then he can take the other courses also. So in this case the answer will be true, and you don't need to really worry about the remaining courses. The other important point is that in order to uh, traverse the graph and find whether there is a cycle, we would be using DFS, which is depth first search. So I'll just briefly talk about it, like what does this mean in case you are not aware of it. So let us look at an example. So I'll just draw a random graph here. So you have few nodes like these, and then by depth first search, which means that if you start at 0, then you try to always go down first, and then when you have exhausted your possibilities of going down, then you traverse your siblings. So basically in this case, you from 0 to 1 you will go, and then you will go from 1 to 2, and since you cannot go down here, now you will start traversing in a uh, breadth way, which means that you will start exploring your siblings. So you will go here, then there are no possibilities to go down, so you will backtrack and then go down to 4. From here you will go down to 5, and then you cannot go down further, so you will come back to 4 and again go down to 6, and this way you traverse the entire graph. So basically these are the nodes or the vertices of your graph, and these are the edges, and the order of traversal has been marked here. So this is a high level idea of how the DFS works. So now we'll look at a couple of examples and see how we can solve this problem. Let's first look at an example where we have no circular dependency or cycles, and then devise a solution so that we can reuse for any other example. So let's look at this example. So here let's take number of courses as 6, so that you have courses numbered from 0 to 5, and then next let us list down the dependencies which are there. So course 0 dependent on 1, then we have course 1 dependent on course 2, then we have course 1 dependent on course 4, then we have 2 dependent on 3, then 3 dependent on 5, and then 4 also dependent on 5. So these are all the conditions which we have. Now let's first visualize like how the graph will be for this particular case. So we have 0 which is dependent on 1, then we have 1 which is dependent on 2, and also we have 1 which is dependent on 4, then we have 2 dependent on 3, 3 is dependent on 5, and then 4 is dependent on 5. So this is the graph of this particular problem of the dependencies which we have. And if you look at this graph, you can see that there are no cycles. So you start from any direction and you will not end up in a cycle. So you go from 0 to 1 to 3 to 5, you end up at 5. Then if you go from this direction 1 to 4 to 5, you also end up at 5, and then there are no cycles, which means that you can always traverse it without revolving around in cycles. So we can say that in this case what we have to return is true. So now with this background in our mind, let's now devise the solution. So the solution will essentially revolve around two things. First is the creation of graph. Okay, so that is the first part of the solution, and the second part of the solution will be to find the cycles in the graph, which we will look in some time from now. So first let's look at how the graph will be for this particular solution. So for this example, so in this case we will use adjacency list representation for a graph, which means that you will have a map in which your key will be the course ID and your value will be the dependent courses. On which dependency is there. So if so basically we have to iterate over the array which has been given, the input array, and then convert this into a map. So this is how the structure will be. Your 0 will depend on just one course, which is course 1. Your course 1 will depend on two courses 2 and 4. Your second course will depend on 3. Your third course will depend on course number 5, and lastly your course number 4 will depend on course number 5. So this is the representation of your prerequisites in the form of a graph. And now so this is the first part of the problem, that you convert your prerequisites array into a graph form, which can be then used to see if there are any cycles or not. So we are now done with the creation of graph. Now let's focus on the creation of a procedure so that we can find out whether a cycle is there or not. So second part of the solution is to find whether there is a cycle. So for this, what we will do is we will maintain two sets. Okay, so let's call the first set as visited. So this is a set, and the second set we can call as all visited. So basically the idea is that these two sets will store course IDs, but they have different purposes. The purpose of visited set is to detect the cycles. So let me write down the purpose, cycles. And this, the purpose of all visited set is to store our results once we have found that a particular course ID can be taken up and it doesn't have any cycle or a dependency issue. So so once we have determined that a course ID can be taken up without any cyclic issue, then we will store it in all visited set. So now with this thing in mind, let's start iterating our graph which we have created here. So first we will go through the first key, which is like the 0th course ID, and the order is not important, but like we have to choose one order so that we can at least start our computation. So that's why I am starting the iteration of keys in this particular order, but the order is not important. The result will always be the same. So if you start with 0, so you will enter 0 in this visited set. Now next we will see where we can reach from 0. So we will look at the values of corresponding to the course ID, and we see that course 0 is dependent on course 1. So we will now add one more value to our set, which is 1. Now we will see that 1 is dependent on 2 and 4. So since we are doing a depth first search, so first we will go to 2, and then we will continue the journey from 2 onwards and not directly come to 4, because we will come to 4 later on. So now 1, now you visit 2, since we are doing a depth first search, and we'll see like how a cycle can be found or will not be found. So now from 2 we know that the dependency of 2 is on 3, so basically maybe I can enter it on the next line, 0 1 2, just cancelling this out, yeah, and then 0 1 2. Now after from 2 has a dependency on 3, so let me write 0 1 2 3. And now so here we are simply traversing our graph in a depth first search manner, and I am just writing it out to make it clear so that we can find out whether there is a cycle or not. Now from 3 we can go to 5, so 0 1 2 3 5, and now from 5 we don't have anything because 5 doesn't have any dependency. So at this point what we will do is we will start to go back or backtrack in our recursion process, because this is essentially DFS is achieved through recursion. I mean, one way of doing that and a convenient way of doing that is through recursion. So now we are backtracking our stacks which we have created, and now we have come back to 3. But in this process of coming back to 3, what we have to also do is that we know that no cycles can be formed from course 5, because till now whatever we have traversed, we did not find any repetition of the same course ID in this particular visited set. So it is clear that fifth course ID can be taken up and there will be no dependency issues or a cyclic issue when you take up course 5. So if you choose to take up course 5, you can take it and there will be no dependencies which will block you from taking course 5. So we will enter this 5 in this all visited set, which means that now we have committed our result which says that course 5 doesn't have any cyclic issues. So now we will continue our backtracking, because if you look at the third course, it has only dependency on 5 and there are no siblings. So we will return the call from third course to second course. So we'll come back, and now our control you can say will be on the second course ID. And now since second also doesn't have any sibling, we will come back to the first course ID, and here we see that first course has dependency on second, which we have already traversed and saw that there was no dependency issue. So now we will go to 4 and we will see like if this particular path from 1 to 4 has any dependency issues or not. So now we will add 4 to our visited array, and now moving onwards, so we'll see that 4 has a dependency on 5, but we at the same time also we see that 5 is already present in all visited, which means that 5 is not having any dependency issues. So now even 4, this particular course ID is clear and it can safely return. Yeah, and one thing which we missed to discuss is that when we were returning from 5 to 3 to 2, we were also making clear that even 3 doesn't have any dependency and 2 also doesn't have any dependency. So when we returned from 5 to 3, we added one more entry. We should have added one more entry to all visited, and then when we returned from 3 to 2, we should have added one more entry to all visited, which is 5 3 and 2. Now when we are returning from 4, because we see that 4 also doesn't have any dependency issues, so we will come back and also add 4 to our all visited set. So now at this point we were here, but now we have come back to the first course, and now even since the first course has exhausted, which means we have looked at both the dependencies 2 and 4, so now we'll come back to 0, and at the same time we will add 1 also to our all visited set, because it is also now cleared for any dependency issues, and now we are at 0. So we'll come back further out and even add 0 to the mix, saying that now even 0 doesn't have any problem. So now once you have done this entire DFS process for course ID 0, you have all visited array which has this entry, and these are all the course IDs which we have determined to have no problem in terms of dependencies, which means that all of these courses can be taken up. And if you look at this set, you see that it has all the courses from 0 to 5. So we continue after 0, we continue our iteration in this particular direction. Now we come to course 1. So every time we look at a particular course for dependency, the first thing which we do is like we check whether it is there in all visited. So we see that 1 is there in all visited, and so we simply bail out from here and say that course 1 is also fine. The same thing we do for 2, the same thing we do for 3, the same thing we do for 4, and for 5th we don't need to do because there is no cycle, no dependency of 5 on any other course. So once we have iterated all the keys in this direction in our graph, in the map which we have created, we see that all the courses are cleared and there is no dependency, and so we can say that there were no cycles and we are good to take up all the courses, and as a result we return true. So let's now look at one more example where we will have a cycle, and this should make the process more clear. We will repeat the same exercise for this next example now. The example which we'll look now is very similar to the last one, with one exception in terms of change in dependency, and that is something which we'll look at now. So again, the number of courses which we have is 6, and the courses are numbered from 0 to 5 this way. And then also let us write down the prerequisites of the course in the form of array. So we have 0 dependent on 1, then we have 1 on 2, then dependency of 1 on 4, then dependency of 2 on 3, then 3 on 5, 4 on 0, and then 4 on 5. So let's first convert this into a graph and look at it visually. So we have 0 dependent on 1, 1 dependent on 2, also 1 dependent on 4, then we have 2 dependent on 3, we have 3 dependent on 5, 4 on 0, and then we have 4 dependent on 5. So this is our graph, and if you see carefully, we have a cycle formation here. So this additional constraint which we have introduced of course 4 on course 0 has caused a cycle to be created. So if you want to do 0, you have to depend on 4, 1 if you want to do it has to depend on 4, and 4 has to be dependent on 0. So you cannot take up all the courses because 0 is dependent on 4 and 4 is dependent on 0. So both of them are dependent on each other and there is a cycle formation, and so in this case we will not be able to take up all the courses, so the result will be false. Now let us follow the same computation process, the two-step process which we saw in the last example. First is the graph creation. So here we will simply iterate through this array and convert this into a map. So our 0 will be the key and then the value will be 1. Then we have 1 as the key and 2 and 4 as the value. Then we have 2 dependent on 3, then we have 3 dependent on 5, then we have 4 dependent on 0 and 5. So this is our map, and now we will start with the second step, which is cycle detection. So for this, as we discussed, that we will have two arrays. One is visited, sorry, two sets. One is visited and then the other one is all visited, and then this is also a set, and we'll start going through the graph, the keys of the graph, which are nothing but the course IDs. So the idea of having two sets is, I'll repeat again, that visited helps us to determine if there is any cycle in the graph, and then this is to store the safe course IDs. By safe I mean the ones which don't have any dependency. So let's start with 0. So first we enter 0, in visited. So before entering anything into visited set, you have to check whether it is already there. So if it is not already there, we enter it. If it is already there, then that means that, you know, the path which we are following from 0 to 1, or from 1 to 4, or 1 to 2, whatever path we are following, there is a cycle in that. So visited helps us to determine whether there is a cycle, and all visited helps us to store those course IDs which do not have any problems in terms of cyclic dependency. So 0 is fine to put here. Then we look at the dependencies of the course 0. So we see that 1 is the dependency. So now we enter 1 because we are doing a depth first search. So we go from 0 to 1, and now we are at 1, and we entered 1 because there was not a 1 in this set already. So maybe I can write it on the next line, 0 and 1. Now we again continue towards the depth first search, I mean towards the depth, I mean downward direction. So we look at this and we see that 1 is dependent on 2. So again we check whether 2 is present in this visited array or set. It's not there, so we enter 2 here. And now again we continue our depth search. So we go from 2 to 3. So we enter a 3 because 3 is not already there. And then same way we add a 5 because 5 is not there. And now 5, while we are at 5, we see that 5 it doesn't have any dependency. So our path has essentially ended, and it till now we haven't seen any cycle. So now we can we can backtrack now. And as we know that when we backtrack, we are sure that the course ID from which we are backtracking, which is 5 in this case, has no cycle. So we can enter this in our all visited set. So now we, after 5, we come to 3, and we see that 3 has a dependency only on 5. So again 3 also can backtrack to 2. So we can enter 3 also in all visited set. And if you look carefully in this graph, so we see that, you know, we can point this to this 5 instead of a separate 5. So you see that 5, if taken, if the course 5th is taken up, it can be taken up without any issues. If you take up course 5, it can be taken up because you can just take a 5 course and a 5th course, and then you can take the 3rd course. So that's why this all visited array is helping us track those course IDs which can be taken up without any problem. Now we come to 2, and we see that 2 is dependent only on 3. So we can again backtrack to 1 and add a 2 also here. So now while we are at 1, we see that we already discovered our path to the 2nd course. So now we have to continue to the sibling course, which is 4. So now what we'll do is we'll add 4 to this set, and since 4 is not already in the visited, we can add it. Now we continue from 4 in a depth first direction. So we see that 4 has a dependency on 0, and we see that we try to add 0 to this visited array, but we see that a 0 is already here. So this means that there is a cycle formation here, and at this point we come to a conclusion that there is a cycle, which means that we cannot take up all the courses. So this is how you can come to the conclusion whether a cycle is there or a cycle is not there. So now let's look at the complexities. If you have enjoyed the discussion so far, if you have found it out to be useful for you, and if you have learned something from it, then please do like this video and subscribe to our channel. And now let's talk about complexity. So first let us look at the space complexity. So basically here whatever prerequisites array we had, what we were doing is, like, we were first converting it into a graph, and then we were traversing that graph. So and then we were using two sets, which is like visited and then we had all visited, represented by V and AV. So and what you the size of both of them combined is the space complexity. So it will be O and the number of courses, because that's the number of vertices. So you will have a O of num, uh, twice of that, but then it sort of equates to O num. So where num is the number of courses you have. So this is your space complexity. And as far as time complexity is concerned, so we are basically converting the prerequisites into a graph, and then we are traversing it in a DFS way. So we can say that the complexity, and we are doing it twice, because once we are iterating the array and converting into a graph, and the other time we are traversing the graph. But for approximation we can say that it's the same as OV plus E, where V is the number of vertices of your graph and E is the edges. So in terms of this problem, it will be a number of courses is your V plus your edges, which is nothing but the length of the prerequisite array. So these two things combined is your time complexity. Let's now look at the code, which should be quite straightforward to follow and relate to the discussion which we had just now. Java to walk through the code, but you can write and transform this code that we'll discuss just now into any language of your choice based on this code walkthrough and the entire discussion we had till now. So let's start with our discussion. Can finish is the actual method which we want to code, which has number of courses and the prerequisites or the dependencies within the courses as the input, and then we have to return whether it is possible to take up all the courses or not. So as we said, it's a two-step process. First is to create a graph. So that is the method also which we have written. So first step is to create the graph, and we have coded a separate method for that, which will take in the prerequisites array and will return the map which has key as integer, which is course ID, and its dependencies will be present in the list of integers, which will be the value. So this entire method looks at your prerequisites array. For example, if this is your prerequisite array 1 2 and then you have 1 3, so you will have something like your key will be 0 and then you will have value as 1, because 0 is dependent on 1, and then your other key will be 1, course ID 1, and it will have dependencies as 2, course ID 2 and course ID 3. So that is how we convert our prerequisites array into a map, and we simply return it. So this is what this entire method does. And then we instantiate our all visited set and the visited set once in the beginning when we are starting to compute whether it is possible to take up of all the courses or not. And then this part of the code is where we actually go through our graph and look at the course IDs which are there in the keys, and we check whether there is any cycle for any particular key. So our has cycle method, which we will look at next, takes in input as the graph which we have just created, key which is the individual course ID which have dependencies, and then this is the visited set, and this is the all visited set which we have instantiated just now. So if for any course ID, if the code finds that there is a cycle, which means that has cycle returns a true value, we return a false, and then we exit, and we don't look for any other course ID which can form a circular dependency, because just one is enough for us to take a decision whether a course can be complete, whether all courses can be taken up or not. So in case we finish this entire for loop without finding a cycle, then we return a true, indicating that there were no cycles and all the courses can be taken up. let's now look at our has cycle method, which according to me is the most important method here. Cycle method, we have four inputs, which I'll just repeat. We have a graph, then we have the current course, which we are trying to check whether it is having any circular dependency. Then we have this visited set, and then we have all visited set, right? The two sets which we discussed before. So for any key or any course ID which we are checking for circular dependency, the first thing is that we check whether it is there in this all visited set, and we know that if it is there in this set, it means that it has no problem in terms of cyclic dependencies, and we can easily take up that course. So in that case, we return that there is no problem and it doesn't have a cycle, and it returns a false. If the course which we are checking currently is there in the visited set, which means the example which we saw, the second example which we saw, which had circular dependency, which had like 0, 1, 2, 3, 5 and 4, and then we again wanted to add a 0. So for such cases, if the current course which we are checking is already present in the current path of dependencies, then we return a true, indicating that we do have a cycle. And in the original method, the top level method, we return a false, stating that we cannot take up all the courses. Now coming to this part, as we discussed, that for whatever course we are checking the dependencies, we keep on adding them to the visited set. So that part is happening here, where we are adding the courses to this visited set, and once we have added it to a set, we want to check its dependencies, and there we get the values. For example, if 0 has dependency on 1, then we in the required courses we will have 1, and we'll continue the same process again. So this has cycle will again call itself, and then it will continue the process of checking whether the further dependencies have any cycle or not. And in case during our iteration we find that there is a cycle, we simply return has cycle, which means that the cycle it's true, and then we don't need to check anything, and we can simply return false from the original method. Otherwise we keep continuing to the other reachable course dependencies in our DFS way. So essentially this method is the entire method is doing your DFS on your input graph. And now when you are done iterating over all the dependencies and you see that there was no cycle found, which means that it didn't return, then we simply add that particular course to our all visited set, indicating that this particular course is fine in terms of dependencies, and also at the same time we return a false, stating that it doesn't have any cycle. So when this method completes and goes over all the course IDs which are there in our graph, then we are able to make a decision. So if a cycle is found, it is upfront we are able to find it out and we are able to return a value. Otherwise at the end of it we simply return false from this method, and as a result of that we return true from our original method, stating that a user can take up all the courses. So with this we can, I think, end our discussion now, and we'll definitely meet in some other video. Thank you for spending your time and listening to us.